Hello, guys, and welcome to Cyber Concoct. This is Emmanuel here, and today I will be discussing on a very important subject, which is subnetting. This is very important, especially if you are looking to improve your networking knowledge or you want to just get the knowledge to help you out in your cybersecurity certifications. So, we will be discussing the features of network ID, broadcast IP, subnet mask, and the rest. So without much talk, let's get into it. But before then, let's look at a few definitions and foundations. So what is subnetting? Subnetting is basically a technique in computer networking that is used to divide IP network into smaller and more manageable subnetworks. So it is used to determine which octet of a particular IP address is reserved for the network and which octet is reserved for the host uh, networks, for the hosts on the networks. So why is this important? It's important because it enhances the performance. Also, it contributes to the security outlook of the network, and then it provides for flexibility. Now, when dealing with subnetting, the major focus is on IP address. So an IP address is a string of numbers that is assigned to devices that communicates over the internet or on a network. So every device that communicates over the internet or on a network must have an IP address. And there are public and private IP addresses. The public IP addresses are what you use to communicate over the internet, and they are generally assigned by the internet service providers. Meanwhile, the private IP addresses are assigned locally on the network, like a local area network. Then there are two versions of this IP address. We have the IPv4 and IPv6. The IPv4 or IP version 4 is a 32-bit uh, group of numbers separated by a dot. So each group is 8 bits. So you have four groups of 8-bit values. All together, you have 32 bits, as you can see uh, by this example here. Then the IP version 6 is a 64-bit architecture. So you have 8 groups of hexadecimal numbers that are separated by a colon. For example, you have an example provided here. Okay, so we'll be focusing on IP version 4 for this subnetting because that is what is usually used. Now, there are different classes in IP version 4. We have the class A that ranges from 1 to 126. So the IP addresses in this particular class can begin from 1.0.0.0 to 126.255.255.255. So in this particular class, the first octet is the network portion. That means the first 8 bits are reserved for the network, while the remaining 3 octets are reserved for the host addresses. And then what this means is that it supports a large number of hosts per network. Also, we have a class B IP that range from 128 to 191. So in this particular class, the first 2 octets are the network portion, and the remaining 2 octets are reserved for the host addresses. Then this is suitable for medium-sized networks. Also, we have the class C IP, and the range is from 192 to 223.255.255.255. In this particular class, the first 3 octets are reserved for the network portion. That is the network mask, the mask bits. And then the last octet is reserved for the host addresses and is very ideal for smaller networks. Now we will be looking at some major features of subnetting, what we are going to provide hacks and tricks to in this particular video. So the first one we'll be looking at is the subnet mask. Your subnet mask is what gives you the interpretation of how many bits are reserved for the particular network, and then how many bits are reserved for the host addresses. For example, you have an example here, 255.255.255.0. In this particular example, the first 24 bits are reserved for the network, while the remaining 8 bits are reserved for the host addresses. Also, we have the total possible IP addresses that are possible on a particular network. For example, the given subnet mask above, we have a total of 256 IP addresses. That is the 8 bits that are reserved for the host addresses. We can have a total of 256 IP addresses. Then we have the usable IP addresses. So out of these 256 IP addresses that are possible on this network, only some are usable. That is, only some can be assigned to actual devices that communicate on that network. And in this case, we have 254 usable IP addresses. Now we have the network ID. The network ID, as the name implies here, is used to identify a particular network, and then it is the same across all the IP addresses on this particular network. So for example, we have something like this, 192.168.1.0. So usually the network ID is the first IP address in the range of IP addresses. And in this particular example here, this is the first IP address and it is the network ID. Now we move on to the broadcast IP. The broadcast IP is the address that is used to communicate to the entire network. So data that is sent to the IP, to the broadcast IP, is simultaneously received by all the IP addresses on the particular network. For example, we have 192.168.1.255 as in this example. Now, before we get into the calculations and the tricks in this subject, I would like to show us a few formulas that we'll be utilizing throughout this video. So we have the total subnets. This is the same as the total possible IP addresses on a particular network, and it is calculated using the formula of 2 raised to the power of 32 minus n. We are using 32 here because the IPv4 is a 32-bit architecture. All right. Then we have the possible hosts, that is the usable IP addresses, and it's usually the total subnets minus 2. Remember, we have the network ID and the broadcast IP. Those are reserved for the special functions, and then the IPs in between can be assigned to individual devices. So in this case, we have the subnets minus 2 to give you the total possible hosts or the usable addresses. Then to calculate the network ID, we have the integer division of IP and the delta n. Here, the IP here is the particular IP address value at the octet of interest. Stay with me. I'm going to explain further in the next section of this video, but for now, just understand that to calculate the network ID, we need to perform an integer division of a particular IP address value at an octet of interest. We perform an integer division by the delta of n. N is the difference between 256 and a particular subnet mask of interest. Again, just stay with me, you understand what I'm talking about in a bit. Then we'll multiply it by the same delta n. Alright, then we have the broadcast IP. Now the IP that we'll obtain from the network ID, we'll have it here, and then we're going to add it um, to this. So we are going to do a subnets, which is what we obtain from this total subnets here, divided by 256 raised to the power of p minus 1. And what is our p? Our p is the index position of target net mask. So if you check the legend here, everything is explained. I will still explain this further in the next section, but just understand this. So to calculate the broadcast IP, we need the network ID, we need the subnet, which is this, and then we need 256 raised to the power of p minus 1. All right. Now, in order to perform these calculations, there are a few steps we have to follow. Now, step 1, we need to determine the subnet mask. Step 2, we need to determine the total subnets, that is the possible IP addresses. And the formula to do this is given this as this. Then step 3, we need to determine the total hosts, that is the usable IP addresses. And this is the formula. Then step 4, we need to calculate the network ID for the particular IP addresses. For example, in this case, 192.134.56.4. It's a subnet mask of this. So whenever you are given an IP address, for example, like this, we need to calculate the network ID for the IP address. And then this is the formula to do that. And then step 5, we are going to calculate the broadcast IP. And this is the formula where your P is the index position of target net mask. Then we are going to perform some examples. All right, so we are in this Excel sheet. Now remember that IP version 4 is a 32-bit architecture. So what that means is that we have 1 all the way to 32. So this is 1 bit, 2 bits, 3 bits, 8 bits, 16 bits, all the way to 32 bits. Now remember that when you are required to calculate or to perform any subnetting calculations, you will be given a cidr range. cidr is short for classless interdomain routing. Now, whenever you are expected to calculate any features or calculations regarding subnetting, you'll be given a range. For example, we have something like 192.168.54.1, for example, /24. You will be given a range, in this case, /24. So what this means is that the first 24 bits have been reserved for the network that the IP address is on. So what this means in this case is that these first 8 bits, 16 bits, and then the first 24 has been reserved for the network. So these bits all the way to the 24th bit have been reserved for the particular network that you are on. So likewise, if we have, for example, 21 here as a cidr value, what this means is that the first 21 bits have been reserved for the network. So what this means is that we have this all the way to 21. So the first 8 bit has been reserved all the way to the 16 bit, and then to the 21st bit here has been reserved for the particular network. This is going to be very important where you want to determine the subnet mask, because now what this means is that the subnet mask, which will be represented by ones in binary format. Hold on, you will understand in a moment what I'm talking about. So the subnet mask is represented by the total number of bits that are reserved for the network, in this case 21. So if similarly we have, let's say, 29, for example, so the first 29 bits have been reserved for the network. So what this means is that we have this all the way to 29. So the first 8 bits has been reserved, the first 24 bits have been reserved, and then all the way to the 29th bit has been reserved for the network. Again, this is going to be very important going forward that you understand this. Now, there is a very important, uh, let's say, word that I've used, and maybe you probably don't understand what it means. So if you look here in these steps, see the first step is to determine the subnet mask, which we will do in a minute. Step 2 is to determine the total subnets all the way. But what I want to show you is this, where it says uh, target octet. So what does this target octet mean? Now, a target octet is the octet where the host addresses begin from. So for example, given this 29 slash 29 cidr value, so we know that these first 29 bits have been reserved for the network, right? And then whatever is leftmost or rightmost of the 29 value that we have is reserved for the host addresses. So I think that this is an error here. It should be rightmost, not leftmost. So right. Okay. So now for this particular slash 29, it means that 30, 31, and 32, these 3 bits have been reserved for the host addresses. And when you look at an IP address, you see the first group of numbers represent the first 8 bits. So the second group represents the first 16 bits or the second 8 bits. So altogether we have 8 bits here reserved, another 8 bits reserved, altogether making 16 bits. Now we have another 8 bits making 24 bits, but now we have reserved 29 bits. So we know that from 24, which is the first 3 octets here, we need to add 5 more bits to complete 29. So we count 1, 2, 3, 4, 5. So these remaining 5 bits are also reserved. So and where does this fall into? It falls into this last octet here, which is supposed to be 8 bits. So the first 5 bits from this octet, this one here, this 8 bits, it has been reserved for the network also. So our host addresses are going to begin from this particular octet. So beginning from 30, 31, 32. This means that our target octet is this one here, this particular octet. Okay, another example. If we have, let's say, 20 slash 20 network, so we'll know that the first 8 bits have been reserved. The second 8 bits, altogether making 16, has been reserved. And then we know that it does not use up the remaining 8 bits, which will make it 24. Okay, so we have 8, 16 here, but 20 here has been reserved also. So we have the first 20 bits have been reserved for the network. Now what this means is that our host addresses, the addresses that we're going to assign to our devices, will begin from the 21st bit here. And where does that fall into? It falls into this second this third octet here. So this will be our octet of interest or our target octet. This is important. I want you to get this. So our target octet will be the octet where the host addresses begin from. So if you are given a /20, so you know our host addresses will begin from 21. Where does 21 fall into? The third octet, which is 1, 2, 3. In this case, this 54 group here. So similarly, if we have, let's say, 24 here, we know we've used up 24 bits. So the host addresses will begin from the 25th bit, which means our target octet will begin from the next octet, which is going to be 1 here. All right. Now, let me go over it. We have 32 bits because IP version 4 is a 32-bit architecture. Then provided the provided cidr value will determine what our subnet mask is, which we will calculate in a moment. Now, to do this, we have determined the subnet mask, determine the total subnets, determine total host available, calculate network ID, calculate the broadcast IP. Now, what is a subnet mask? For this particular example, the subnet mask is going to represent the number of bits that have been reserved for the network. We have a /24 network. So what this means is that the first octet, that is the first 8 bits, has been filled up and reserved. So we are going to have a full octet. So similarly, the second octet here has also been filled up because this is /24. So we have 8 bits reserved, which is full, 16 bits reserved, which is another full octet, and then the 24th, all down to the 24th bit, has also been reserved, which is a full octet. So in this case, our subnet mask is going to be 255.255.255.0. Why is this so? Because 24 bits have been reserved for the network. What does that mean? It means the first 8 bits are filled up, which amounts to 255. The second octet has been filled up, which amounts to 255. And then the third octet, which amounts to 24 bits, has also been filled up. So we have 8 here, 8 bits here, 8 bits here, and another 8 bits. 8 times 3 makes 24. And they are filled up, which amounts to 255. Now you might ask, how did we arrive at 255? So let me explain here. An octet, let's say 1, 2, 3, 4, 5, 6, 7, 8. This is one octet because it's 8 bits. Then another octet, 1, 2, 3, 4, 5, 6, 7, 8. Another octet. Then the third octet, 1, 2, 3, 4, 5, 6, 7, 8. Then the last 8 bits, which is going to be 0. Now, if you calculate these ones here, so this 1, 2, 3, they all amount all to what? 24, because this is a /24 network. So if we have a /16, for example, if this were to be a /16, so this here will also be 0, because now we are only reserving the first 16 bits for the network, which amounts to 16. So now by the time you convert this to decimal, you have 255. You convert the next 8 bits, which is filled with ones, to decimal, you have 255. And then because it is /24 network, we also have a full 8 bits here. So by the time you convert this also to decimal, you have 255. And then this 0 to decimal is also 0. So that's why we have 255.255.255.20.0 here as the subnet mask. Please stay with me. The next session will explain this better and in more detail. All right, last illustration before we begin to solve some exercises. So if we have a CIDR range of 192.168.5.1 in a /24 network, now the network bits will be 24. The host bits will be 8. That is 32 bits minus 24 bits reserved for the network, which gives us 8 bits. Now the bits are represented as below. So the network bits are represented by ones, and then the host bits are represented by zeros. So these are the network bits, and these are the host bits. Now, the octet of interest that I mentioned earlier is the octet where the host bits begin from, the rightmost octet, which is at index 0 or position 0, as the case may be. All right. Then the subnet mask is calculated by converting the network bits to decimal value. So in this case, the first octet, the first 8 bits, is converted to decimal, which gives us 255. The second octet is converted to decimal, which amounts to 255 also. Likewise, this octet, and then the final octet, which is also 0. All right. In the next session, we are going to begin calculations on some examples. Okay, the first exercise we have here is the 192.134.56.4 in a /24 network. Already we know that the network bits are 24. So the first step is to determine the subnet mask, which is going to be 255.255.255.0 from the illustrations that I've already explained. Now, step 2, determine the total subnets. The total subnet is the number of possible IP addresses that are possible on this particular network. And the formula to do that is 2 raised to the power of 32 minus n. Now, remember that we are looking for the possible IP addresses, and it's going to be determined by the remaining host bits. All right, so we have that 2 raised to the power of 32 minus 24, which gives us 256 possible IP addresses. Now, step 3 is to determine the total hosts, that is the usable IP addresses. Out of these 256 IP addresses that we have here, only some are assignable to actual devices. And now the formula to do that is subnets minus 2. So what we get here, minus 2. We are subtracting 2 from this because the network ID and the broadcast IP cannot be assigned to devices on the network. These are special IP addresses and they are reserved for special functions. So when we substitute these values into the formula, we have 256, which is the subnets, total subnets, minus 2, which gives us 254 hosts. Now, the step 4 is to calculate the network ID for the IP. Now, this is where things get a little interesting. Our IP address is 192.134.56.4 in a /24 network. And we already know that the subnet mask is 255, 255, 255.0 from above here. Now, this is the formula to do this. Remember, I said IP in an integer division by delta n, then multiply everything by delta n. Now, our dn or delta n is the net mask difference at the octet of interest or the target octet. Now, remember why that was important that I emphasized it. Now, remember in this /24 network, the host bits begin from this particular octet here, where this 4 is. So Similarly, the target subnet mask is 0, right? So this is the target octet, this last one, this rightmost octet, which is 0 and 4. Now we are going to perform a net mask difference, which is 256 minus 0, which will give us 256. Substituting that into the formula, we have 4 because 4 is at the octet of interest. 4 is at the target octet. Now 4, then we perform an integer division by delta n, which we already have here as 256. What an integer division is, we divide 4 by 256, and we are only interested in the whole number result, not the remainders. So if 4 divided by 256 is 0 point dash that, we are only interested in that whole number result, that is the 0. Whatever is remaining is not our concern, it's not of interest to us. So we do an integer division of 4 by 256, then multiply it by 256, which gives us 0, because 0 is the result of this integer division, multiply by 256, which gives us 0. So the IP address begins from 0, right? So our network ID, which is going to be 192.168.56, which is this, and then .0, that's going to be the network ID, and it is the first IP address in the range of networks. Remember, after the network bits, the host bits begin, and then the first IP address in the possible IP addresses is the network ID, which in this case is 0. So we substitute that into the whole IP addresses which were given. It's going to be 192.168.56.0. Okay. Now we have to calculate the broadcast IP. So the formula to do this is network ID, which is the 0 that we obtain here, plus then in bracket the subnets, which is the total subnets, which is 256, divided by 256 raised to the power of p minus 1. Now remember our p. Our p is the position of the octet of interest, or the target octet. In this case, our target octet is 0 because we are in a /24, and because that is where the host addresses begin from. So the target octet is this 0, and it is at index 0 or position 0 beginning from the right. So this is position 0, as we have seen here, position 0, position 1, position 2, all the way to position 3. So we are only interested in the position of our target octet, which is 0. Now substituting everything into the formula, we have this 0, which is our network ID that we've gotten here, plus in bracket 256, which is the total subnets which we got here from this step 2, divided by 256 raised to power 0, because our p is 0, because the position here is 0. Our octet of target is at position 0, then minus 1. What that amounts to is 0 plus 256 minus 1, which gives us 255. So the broadcast IP, when we substitute that into the range, is 192.168.56.255. So this is the last IP address in this range. Okay, so the first IP address, which is the network ID, is 192.168.56.0, which we have found. And then the last one, which is the broadcast IP, is the 192.168.56.255, which is the end of the IP addresses in this range. Let's move on to the next exercise to understand better. So, provided we have 150.34.62.10 in a /19 network. Now, what this tells us is that the network bits are 19. Okay, so determine the subnet mask. The subnet mask is going to be 255.255.224. Okay, so why 224? Because the first 16 bits are reserved and they are full. Now, to get 19, we have to add some bits to 16 to get 19. So we added 3 extra bits, which is 1, 1, 1, 2, 16 to get 19, right? And it is at the this octet here. That is it, this 62 octet. So converting that to decimal, the first 8 bits converted to decimal is 255. Now, the second 8 bits converted to decimal is 255. Now, the third octet, which consists of 1, 1, 1 and remaining zeros converted to decimal is 224, which is also our octet of interest or target octet. Now, that was 0. All right. So the step 2 is to determine the total subnets, which is the possible IP addresses in this range. And the formula to do that is 2 raised to the power 32 minus n. Our n is the total network bits. So we have a total of 8,192 possible IP addresses. Step 3, determine total hosts, that is the usable IP addresses. And remember, it's the subnets minus 2. So we have 8,192 minus 2, which gives us 8,190 usable IP addresses. Now, step 4 is to calculate the network ID. Again, what is our octet of interest, our target octet? Is this octet here 62? Because we are in the /19 network. And then /19 belongs to this, counting from here, 8, 16, and then we have 19 in this particular octet. And then we have the subnet mask calculated from here already to be 255.255.224.0. Now, the formula for this is, remember, we perform an integer division of the IP at the octet of interest, which is 62. We perform an integer division by delta n. Remember our delta n? Our delta n is 256 minus the subnet mask at the octet of interest, which is 224. So our dn here is 256 minus 224, which gives us 82. Substituting everything into the formula, we have 62 divided by 32, which is an integer division. We are only interested in the whole number result. We don't want whatever is remaining. So 62 divided by 32, we get 1 remainder what? We don't want what is remaining. So then we multiply it by 32. So now the result of this 62 integer division of 32 is 1, because 32 can only go into 62 one time. Remember, reminder 30, right? But we are not interested in the 30. Okay, so we only pick that one multiplied by 32, because from the formula we have integer division multiplied by delta n, which is 32. So we are having 1 times 32, which is 32 here, and that is the network ID. So substituting this 32 into this range and then turning everything, write most of that to 0, we have 150.34.32, which is what we have calculated at the octet of interest. And then whatever octet is rightmost of our octet of interest is turned to 0. Therefore, our network ID is 150.34.32.0. Now, to calculate the broadcast IP, we use the formula network ID plus in bracket subnet divided by 256 raised to the power of p minus 1. Remember, what is our network ID that we calculated? We just calculated 32 as our network ID, right? So substitute that into the formula. Now, our P is 1. Remember, the target octet, because from this IP range, 150.34.62.10 in a slash 19, our target octet is this one. And then counting from the right, we have position 0, position 1, and that is what we want. So our P here is 1. So substituting everything into the formula, we have 32, which is the network ID value that we calculated. Then the subnets, which is this 8,192 that we calculated from step 2, divided by 256 raised to the power of p. What is our p? P is the index position of our octet of interest or our target octet, then minus 1. So what that gives us is 32 plus 32 minus 1, which gives us 63. Now, as opposed to network ID, where we convert every other octet, write most of our target octet to 0, in the case of broadcast IP, any other octet, write most of our target octet is converted to 255. It's rounded up to 255. So we've calculated and we've got 63 as our broadcast IP. So we substitute that 63 into the IP range that we are given, and then whatever octet is rightmost of our target octet is rounded up to 255. All right, let's perform one more exercise to drive this in. So we have 222.138.9.2/26. So our network bits are 26. What this means is that the first 26 bits are reserved. So step 1, we determine the subnet mask. Okay, so remember, in a 26 network, the first 8 bits is filled up. So 1 in 8 places, that is the first octet. Convert it to decimal, we have 255. So the second octet, which is also filled up, 1 in 8 places, converted to decimal, 255. The third octet, which amounts to 24 bits, also filled up with ones in 8 places. Convert it to decimal, we have 255. Now, the third octet stops at 24 bits, right? But we are given a slash 26 bits. So we need 2 more to complete 26 bits. So adding 2 more bits to our 24 will get 26, right? So in this final octet, which is going to be our octet of interest, the first 2 bits are also reserved for the network. So the first 2 bits of these 8 bits are going to be represented by 1. So we have 1, 1, and then the remaining 6 bits are zeros because there are 8 bits. The first 2 are also reserved for the network. The remaining 6 are zeros reserved for the host addresses. So converting 1, 1, and then 6 other zeros in binary to decimal will give you 192. That is how we got this 255.255.255.192 as our subnet mask. Step 2, determine the total subnets, that is the possible IP addresses. And the formula is 2 to the power of 32 minus n. Our n is 26. So when we do that, we get a total possible of 64 IP addresses. Step 3 is to determine the total hosts usable IP addresses. So remember, our subnet minus 2. What are the two? We are removing the network ID and the broadcast IP because they are special and we cannot assign them to actual devices. So the total usable IP addresses are 62 hosts. Now step 4, we need to calculate the network ID for the IP. Now our octet of interest is this 2 here because this is where the host addresses begin from. So the 27th bit is contained in this octet. Likewise, this is our octet of interest also. So using the same formula, integer division of the IP and then the delta n multiplied by delta n. Remember, what is our IP? Our IP here is the IP address at the octet of interest. In this place, we have 2. This is the IP we are interested in. What is our delta n? Is the difference between 256 and the subnet mask at the octet of interest, which is 192. So when we subtract that, we have 64. Now, putting that into our formula, the integer division of 2 into 64, because our IP address is 2 at the octet of interest, divided by delta n, which is 256 minus 192. 2 divided by 64, we get 0 remainder. We are not interested in what is remaining, so we pick that 0. So we do 0 multiplied by 64, which is equal to 0. Therefore, our network ID is 222.138.9.0. All right. Now, the final step is to calculate the broadcast IP. The formula is the network ID, which we have calculated here to be 0 before substituting it. We have network ID of 0, the subnet, which is 64, and then 256 raised to the power of p minus 1. What is our p? Our p is the index position of the target octet, which is at position 0, counting from the rightmost of our range. So p is equal to 0. Substituting everything into the formula, we have 0, which is our network ID, plus in bracket subnet, the total subnet, which is 64, divided by 256 raised to the power of p, and our p is 0 because our target octet is at position 0 minus 1. So 256 raised to the power of 0 is 1. Therefore, we have 0 plus 64 minus 1, which is equal to 63. Therefore, our broadcast IP is 222.138.9.63, which is our broadcast IP address. Now, I want you to perform this exercise and let me know your answers in the comment section below. I want you to calculate the subnet mask, calculate the total possible IP addresses, calculate the total usable IP addresses. I want you to calculate the network ID and then the broadcast IP, and then type your answers in the comment section below. So what you're going to do is 207.34.54.1/21. A bit of a hint, you have 21 bits reserved for the network. So perform this and let me know your answers in the comment section below. All right. If you've made it this far, please consider liking and subscribing to the channel. Thank you. Otherwise, see you in the next video.